Good evening to one and all present here. So this is the session 7 on data science for engineers course. So today we are going to learn about the last session we learn about the regression problem. In this section we are learning about the classification, what exactly it means. So there are two very basic problems in the machine learning. So here we already learned one thing, regression means when we want to predict some value and all. Here we are going to learn about classification where we want to distinguish between the two kind of components you can see. So we will see what exactly it means in the day. Okay. So before that, we will learn about parameter and hyperparameter. That's the one of the topic which is covered during this week. So in one of the, I think, fourth or fifth session, we already discussed on this part. But in detail, we are going to learn about parameters and hyperparameter. What it exactly means? So, so this is a very basic distinction between the parameter and hyperparameter. Okay. So parameter, so this is you are able to see in this sense. So parameter is something estimated during the training with historical data. So it is very simple definition. When you will get something, when you train your model, while training of your model, that is called to be a parameter. Okay. And the value which are set beforehand by you are called to be the hyperparameter. Okay. So let's understand this with the help of basic example of linear regression. So in the linear regression, when we have a particular equation y is equals to ax1 plus bx2, so a and b are your kind of a parameter, which is you can say your slopes as well as the intercept of what of your that particular line. Okay, so that parameter you will get, that is called to be the parameter. Okay, means if you consider the single dimension, then y is equal to mx plus c. So m is the slope and c is the intercept, which we will find after the training of the model. Okay, initially we choose some random value and then we optimize our whole kind of that particular line. So it will rotate and it will reach at particular point where you will get a minimum error. So that point you will get some slope and intercept value. So those value are called to be the parameter. Okay, that is the example of parameter. Then what is hyperparameter? So hyperparameter are something which we will set beforehand. Okay, that is a responsibility of the user to set what exactly it means. Okay, so the example for this, there are different algorithms such as kind of k nearest neighbor algorithm where you want to choose how many number of nearest neighbor I want to give to my algorithm. Okay. Or the another example is the neural networks. How many kind of what rate I want to with which means I want to train my model. How many epoch I want to means how many times I want to retrain my model, all those called to be the epoch of the model. So all those are decided by you. Means you need something beforehand. Okay. So that is called to be the hyperparameter. Okay. So it is a part of the model. Means alpha, beta. That's what I just told you. In the case of neural network, it's called to the weights. Okay. So those are kind of a part of the part of your model. And hyperparameter external to the model. External means it is a part of the model. You can say, but it can be means it is asked to the user, please give me this, and then after that, based upon that, the model is going to be trained. So it is the external part of the model. Then the estimated value is saved with the trained model. Okay, so this is already saved, means saved with the trained model means those alpha and beta value will be saved with the model, not a part of the trained model. Hence, values are not saved. So these values are not saved. You can change anytime this value, and based upon the training will happen. So dependent on the data set means these value are dependent upon data set, because if your data set change, then these alpha and beta value also change. Whereas these value are not dependent upon the data set. That is very basic difference between the parameters and the hyperparameter. We will see in deep bit examples. Okay, that will help you to understand. So one of the example here is the neural network models. Okay, so here model design and kind of a hyperparameters. Okay, so layer, activation function, optimizer. Okay, all these are the building blocks of your model. So to train the model, you require one is the model design and the hyperparameter. But for the model design also, you require how many layers I want to choose, or how many what is activation function, or what exactly the loss function I should choose. So all this can be a part of what you can say the hyperparameter. So here you how much learning rate I should choose, or where to you means in the linear regression also, at which particular point I have to stop my learning, means when you're calculating the mean absolute error or mean square error, so at what point I should stop to go further. Okay, if it's raised to the 10 to the power minus 3 or 10 raised to the power minus 4, you are applying the stopping mechanism, so you can consider that as a hyperparameter. Okay, that is not coming from the data set or any, and with this you will train a model. Okay, so that will give, any model is nothing but a finding a exact or near to that particular natural distribution parameters. Okay, so that will give you a no model parameter, and that is nothing but a model. So the variable learned from the data, that is called to be the weights. In neural network we will generally get the weights. Okay, so if you consider the LLM or even the chart gpt, so chart gpt is nothing but a weights. Okay, small means a numerical weights assigned to a particular model. Okay, that is you will get after the training of the model. So that's called to be the model parameter. That is very basic difference between the hyperparameter and the parameter. Now, how to select this hyperparameter, that is also one of the tasks. Okay, so hyperparameter, there is no hard and fast choice. Okay, sometimes something works for particular model training, and sometimes it not works. So it's a iterative process. Okay, so based upon of particular iterations, you have to choose which parameter best fits for your particular data set. So how to select these hyperparameters? So you have the data set. So what if you have the very big data set? Okay, some lakhs or 10 lakhs of points, sample points. So first, what we generally do, we will divide this data set into training, then the validation and the test data set. So like that, we divided this. Okay, so on training data set, we generally train our model. Okay, what exactly like a logistic relation on decision teams, and then once this is trained, so what we will do, we will tune the hyperparameter. Okay, so for this logistic regression model, whatever trained here, okay, so we will validate, means within this trained model, we will change up in case of a decision tree, there are how many layers I want to go in there, or in k nearest neighbor, how many nearest neighbor I want to choose. So what we will do, we will take this training data, and based upon this training data, we will train model with different parameters, that is called, sorry, different hyperparameters, and then we will validate this with the particular this particular validation data. And once that, whatever the model we will get, we will evaluate that on the test data. So like that, this training, validation and test data is divided, and based upon that validation data, we will choose the hyperparameter. But this is not always the case. You will not get the training data, means you will not get the 1 lakh points at 1 lakh sample points to train the data. There are so many cases in the real life industry. You will just have 100 or 200 or some thousand points. So in that case, it's very difficult to divide this whole data into training, validation, and test. So in that case, scientists come up with some different approach. So what they will do? So let's consider that is called, these are kind of two methods which are taken during during this course. So which one of them is called to the leave one out cross validation, okay, and another one is the k-fold cross validation. So let's assume these are the single variable v2, okay, and each particular this value represents a sample. Okay. Now leave one out cross validation. What exactly it means? So this is, you have the data. So what you will do? You will take this from 23 to 42 all values. Okay. You will train the model, and what you will do? You will test that whatever the model, whatever the weights you got. So you will test that model on this particular value 02. Okay, so then again, what you will do? You will consider, you will leave this particular 42 out, and then 60, and at the end 23. So like that, you will train your model n times. Means if you consider there are this around 25 kind of a sample, if you consider here, so you will run your model 25 times, and you will take the average of all the errors during all these 23 times, whatever the you got, and like that you will do this for all hyperparameters. Means first, you will choose kind of a 3k nearest number, then 4k nearest number. Like that, you will choose different k nearest number, and based upon that, you will you will do the average, and based upon that, you will do the plotting, and then one which gives a less number of error, that particular hyperparameter you will choose. So that is a leave one out. Okay, but here you can see you have to do an iteration of training the model, but sometimes training the model is very costly. Okay, so they come up with a new approach that is called to the k-fold cross validation. So in that case, what they did, so in that case, they divided this whole into a specific chunks. That is why they call it as a k. K means how means they divided this whole data set into the k parts. Okay, so k, that's why they called it as a k fold, and it's cross validation. Okay, so here we are able to see one, two, three, four, five. So this is I think 25 points. So they divided this into the five k five folds. Okay, so what they will do in the initial four fold, they will train their model, and at the whatever the remaining five, okay, these are yellow portion you are able to see, there they will validate their model, okay, and they will test their model. So right now here you have to just train up your model five times, and you will get a kind of approximate what exactly hyperparameter use. But in this case, you have to train it for the 25 times. It is a better approach, but it will take a long time. With the help of K cross validation method, it is reduce your time kind of a five times. Okay, so even if yeah, you are able to what you can say get a lesser accuracy, but within a small amount of time, then it's fine. Okay, so there is always trade-off in between the time and the accuracy. Okay, so that is called to be the cross K hold cross validation. Okay, moving towards, so this is one of the example of selection of hyperparameter. So in this graph, you are able to see this is on the y-axis mean square error is the shown for the neural network model. So neural network model is kind of which is inspired by our brain neural cells, okay, which consist of the neurons and the number of layers and the neurons. Okay, so one of the hyperparameter is their layers and number of neurons. Okay, so on the x-axis, the neurons are given, and this ray and this particular orange and the pink color shows how many number of hidden layers should be there. So pink represents the hidden layer, one hidden layer, and the orange represents two hidden layer with this different 2, 4, 6, 8, 10, 12 neurons. Okay. So when cross-validation is performed, the best hyperparameter are chosen as two hidden layers with 10 neurons. So I already told you. So initially they perform it on the one neuron with one layer, and then one neuron with two layer. So for each of that, they calculate the accuracy, and you are able to. So they are able. They calculate the error. And you are able to see the minimum error they will get for this particular point. So where your number of layers is 2, whereas your number of neurons in each layer is 10. So at this point, you are getting the less mean square error, and that's why you can choose this, and that will give you the highest, you can say, accuracy of your model. So that's how the selection of hyperparameter is done. Then let's move towards some numerical. So what is the primary purpose of cross-validation in machine learning? So that is the question. So what is the purpose of cross-validation? Okay. Read the options, means all the four options properly. What is the primary purpose of cross-validation? So the correct option is the B. Okay. The main aim is not to train a multiple model simultaneously for faster conversation. The aim is to evaluate the model performance and access its generality on unseen data. So that's what main purpose, and with that you will get a kind of your hyperparameter as well. So that is the main objective of the cross validation. So whenever you are training your model, okay, neural network or something, so in that case your one epoch will run. So it will train your model, and then it will validate your model on that particular validation data. Okay, so that you means what exactly this validation data means. Here we are all able to see. So this is your seen data. I mean, this data is utilized for training, and then we have to validate our model on the testing data, or you can say the validation data. So the main purpose of this is to validate this particular on unseen data, so that your model is generalized model. Otherwise, it's called to be the overfitted model. Means it learn a full all things in the training data, but not able to perform good on the testing data. Okay. So it helps to estimate how well the model will perform on new unseen data by simulating the process of training and testing on different subset of the data. So that's the main purpose of validation of the model. Next question is, which of the following is not commonly used cross validation technique? So these are different cross validation technique which is not utilized for the cross validation. Okay. So it's a straightforward answer. Yeah, okay. So the correct answer is D. From I think just after reading the means in all the three first option, the cross validation is given. But that way also you can figure it out. The D is the correct answer. So train tested is basically you want to split your data set into two, but that's what exactly it means. So it is not any kind of a cross validation technique, or so that D is the correct answer. Okay. So next one is the which statement is best describe the leave cross validation method. So we just saw leave one out cross validation. From the name itself, you can able to answer it. Yes, Jagananda Rao answer it as C. Prakash was answered as C. So yeah, you are correct. The correct answer for this is a C. It uses a single, so that's what exactly leave one out means. You should. It uses single data point to testing and remaining data for training of the model. So that's why C is the correct answer for this. Okay. The next question is which of the following is an example of a hyperparameter? So there are different examples are given. Which one is the hyperparameter? I'm asking about the hyperparameters. Okay, so most of you answered is A, but the correct answer is B. So the weights of a neural network's hidden layer. So these are the weights of neural network hidden layers you will get after the training of the model. Okay, so that's why this is kind of a your parameter and not a hyperparameter. You will not initialize the weight from your because you don't know how means that's what exactly neural network model give you. It will after training it will give you the weight. So hidden layers of means the weights of a hidden layer is a parameter and not a hyperparameter. But the learning rate of a optimization algorithm, how much learning rate you want to put means learning rate means you want what exactly the value you have to mention while doing the training of the neural network model. Okay, so that's why learning rate is an optimization algorithm. So I think here also we while giving that yeah, so here also you are able to see the learning rate hyperparameter. And here you are able to see the variable learned from the data is called to the weights. So this is the neural network example. So the weights you will get during the model training, and that's why B is the correct answer for that. Okay. So first think about whether I am getting this it is dependent upon the data set or not, or it is kind of given by the user. If it's initially given by the user before starting of the training, then it is called to be the hyperparameter. Okay, that's a very basic difference. Okay, so moving towards our main part. So that's how what we still now we talked about the hyperparameter and parameter. Hope you understand all of you. So starting with classification. So classification is a supervised learning. So supervised learning means you have some input samples and based upon that some output is assigned to that. Okay, so like that, such kind of a data set on which model will train. It's called to be the supervised learning that assigns class to data points. Okay, so this is the classification is particular supervised learning assign a class to a data points. Okay. So let's understand this with the help of a particular this particular image. So here there you are able to see data coming to your particular. Let's consider you have the HR. Okay, so in HR, when someone is HR, okay, so he will receive the data from Drive. Okay, he will receive the data from the Dropbox. He will receive the data in the form of incoming attachment to the mail. Okay, so he want to divide this whatever the data coming to him into different departments. So initially, it's very difficult for him to look into each one of the data, what exactly the documents is coming, and based upon that, he is all the things he is doing manually. Okay, but you know right now there are so many large language models and so many NLP tasks you can perform, and based upon that, what happen? You build a particular model. Right now, you want to make the job of HR very easy. What are the mails coming to him? He will forward based upon the information hidden in the PDFs, whatever the attachments sent to them. So if we generally consider PDFs are the kind of attachment you will get. So based upon that, he will, if it's an invoice, it is going to be uploaded to the accounting team. If it's a CV, then it is going to be sent to the HR, recruitment, and all those people. And then next one, it is if it's a proposal, it is forwarded to the procurement department. Okay, so like that, you can create your classification. So what exactly happening here? Some particular thing here in it's kind of an input data is coming that is up in the form of PDF document, and you are classifying data. You are dividing that data means you created here three classes. Okay, so invoice, CV, and proposal. So that is called to the class, or you can say also the target. So you created a three target, and whatever the document will come, it is going to be divided into either invoice, either CV, or the proposal. So that is called to the classification problem. Okay. So the example of this is the email spam detection. Okay. So whatever here you are able to see, the email is sent to you. So email is either a spam mail. Okay, if it's a spam mail, it will be directly sent to your Gmail box. Okay, it will be stored in your Gmail box spam folder. Okay, so that is one of the example of a classification algorithm. Sentiment analysis. Okay, so you know the Twitter and other places, so they are what you can say, they are they are tweeting something. Okay, so whether what at what sentiment they are tweeting, whether they are angry or they are happy, what exactly sentiment based upon whatever that they tweeted. So that is one of the classification problem. Image classification. Okay, so right now many of you utilizing your mobile and the Google lenses and all. So once you click on the Google lens and you are able to see, that will give you this means if you just capture the photo, that will tell you, okay, you are at the photo which is just to calculate means captured. So this is the photo of a food, or in your gallery, means you are able to see the photos are segregated based upon the colors. So red, white, green, all those colors are kind of a classes. Or you are able to see your mobile also saves the photo based upon the faces of particular person. So that is called to be the classification based upon your faces, or classification based upon a specific event. So all those are utilizing the classification. Medical diagnosis. So you went to the hospital and you can say cancer hospital. So if they are utilizing the AI based model, so for the cancer diagnosis, so it's cancer, that particular patient is cancerous or non-cancerous. And then fraud detection, whether means fraud detection means in the bank someone is able to uh, repay the loan whatever he taken. So whether should we give him the loan or not, so that is another. Then language identification, when you click on the Google Translate, so it will, I mean, when you click on the photo, it will, let's take the example of a Google Lens. Okay, so in the Google Lens, it automatically detect which kind of language it is. So that is nothing but a classification problem. Okay, so already something is fitted that convert the image into the text, and that text is compared with the all different kinds of what you consider the languages, and then that particular language is detected. So these are the different examples in your day-to-day life we are utilizing as classification problem, but we don't know this is called to be the classification problem. That's the difference. Okay. So we will go in depth about the classification. So there are different types of a classification. Okay. The first one is the binary classification. So here only two classes will be there. So here we have the crosses and the circles. Okay, which represents the data of which are x1 and x2. So if I want to divide this, so what I will do, I will just create this particular means this particular boundary, so green boundary. So green boundary is nothing but you can call this is generally called a particular decision boundary. Okay. So based upon this line, if it's above this line, then it's called to be the crosses, and below this line is called to be the circles. Okay. So why we are means this is kind of a eight data points we have. So why we want to train this particular classification? So doing the classification, okay, generally when we train the model, we are going to get the particular value. In linear regression, we will get such kind of elements. Okay. In the kind of a classification problem, we are going to get a boundary. Okay. So this is the boundary. Once you train the model, we will get the weights of this particular boundary, slope and intercept of this particular line. Okay. So that will divide this into a two portions or the two parts. Okay. So that's what we will get in the classification problem. Okay. So this is binary because only two classes are there. Then next one is the multi-class classification. So that is called where multiple classes are there. Here we just have the two circles and the crosses. Here we have squares, triangles, and the crosses. So here, if I do this classification with only one line, it's not possible. Okay. So here I require at least two lines. Okay. Here three lines are given, but this can easily done with the help of two lines also. So here, if we just remove this green line, then also with the help of this line, whatever the blue and the red line, you are easily able to separate these three classes. Okay, so that's what if there are multiple classes are involved. So that is called to the multi-class classification example. So the real life example for this here you can say spam and ham mail is one of the example for binary classes. Multi-class classification example is kind of a detection of your detection of what exactly the language. So there are many languages spoken in the India, and based upon whatever your script, okay, Devanagari or other script, your Google Lens going to detect what kind of language it is, and it will translate into the English. Okay, that is the example of multi-class classification. Moving towards next, so another way to classify it based upon the decision boundary. Okay, so here I already told you the decision boundary is responsible for dividation of this data. So these are blue points and these are the green points. So here, if this is the kind of a diagonal line you are able to see, so that is dividing this into the two portions. Okay, but this is a very kind of you can say the ideal data. Okay, but if you get a data like this, okay, where which is very non-linear data, so whatever the line, if you try to draw this kind of line here, here, or here, you are not able to divide this data into the two portions. Okay. So the best way to come up with just to draw a kind of a circle. Okay. So circle is kind of a non-linear decision boundary. So that is the way here you are able to see a linear and the non-linear decision boundary to divide your means that is also help you to create a taxonomy in the classification problem. Moving towards next, so we are going to see. So this is the one of the linear regression. So logistic regression is one of kind of a help to draw a linear boundary. Okay, so that's algorithm we are going to see here. Okay, so that is called to be the logistic regression. Okay, so regression, linear regression is different, which is utilized for the regression purpose. Logistic regression basically we utilize for a classification problem. So classification is a technique which draw a linear down means. So logistic regression is a kind of technique which draw a linear boundary. Okay, where we will not get a non-linear boundary. Okay, goal. What's our goal here? Given new sample data predicts the class from which the data points likely to have originated. Okay, so here these are our kind of a training sample. When a next sample comes to this particular space, so let's consider here a new sample comes. So this represents that this particular sample is coming from the blue kind of this particular class, okay, and not from the green class, okay. So that will help us to classify between the points, okay. Now, simply guess of a class is not a good way to classify the sample here. Hence, probability is introduced to produce a better understanding, okay. So always saying a black and white is not a good way to tell. Okay, this is either a spam mail or the ham mail. That's not a better way to tell. But if you assign a particular kind of a spectrum, okay, so it's like I'm saying a black and a white. So instead of that, if there is a black on the extreme left and a white on the extreme right, so you will get a very kind of a good spectrum of gray also. Okay, from white to a particular black. So similarly, here rather than saying, okay, let's consider this example here, either saying kind of a circles or the crosses. It is coming from here. Okay, So it's better to tell this in the form of a probability. Okay. So this is that much probable because here you are able to see if it is coming, if it is this particular point. Okay. So this is very, I mean, this is your decision boundary. If this is very near to your decision boundary, okay, then also it is considered to be the cross. Okay. But here there are some kind of a characteristic which might match with this circles as well because this is very near to this particular point. Okay. So here in such case we can give the probability measure that the probability of belong to this particular cross section, okay, have kind of a 0.55 and belonging to the circles of green, that is 0.45. So the total of probability is 1. Okay. So that will tell you or tell you more extra story that this particular, if you do a small changes, it might shift to the another class. Okay. Because its some features are similar to that of the another class. So that will help you to give a spectrum. So now, to model the probability, to classify the two classes, we use decision boundary. Okay, that's what we told right now. So here you are able to see this is kind of a decision boundary created, that is z is equals to 6 minus x1. So here whatever the x1 value put, okay. So if you put x1 is equals to 6, okay. So if you put it's equal to 6, then z is equals to 0. Okay. If you put this is equals to 5, then 6 minus 5, it becomes 1. So if the value of a z is plus, then it is belongs to the green, and if its value is negative, then it belongs to the process. Okay, so that way you can what you can say interpret how this decision boundary takes. So this particular equation, okay. So this z value right now can take means if you go to the minus infinity, so 6 minus minus infinity, then you will get something kind of a infinity values. So z value changes from minus infinity to the plus infinity. Okay. So to bring this, okay, hold this minus infinity to the plus infinity into the 0 and 1 range, we generally utilize the function that is called as the sigmoid function. So what this particular sigmoid functions do? So sigmoid function, what exactly it do? It will take that particular z value. Okay, here we consider it as a x. So it will take that x value, and then if you put that x value, if that x value reaches to minus infinity, then you are reaching to 0. Here you are able to see the graph. And if it goes to plus infinity, then you are going to reach to 1 value. Okay, so that's how it is what you can say transforming your minus infinity to the plus infinity range into the 0 and 1 range. So that way you can interpret this as a probability that if my probability is kind of a zero point 0.5, then there is an equal contribution from both the classes. Okay, that's why you can say that this sample, what you can say, with the help of human or any extra expert, you can validate whatever the samples you got there, whether it's belonging to which class, because your algorithm is not able to figure out it is belong to which class. Okay, so that is the way to tackle the problem of minus infinity to the plus infinity and come up with a more better approach to do the classification. Okay. Now, moving towards the mathematics of logistic regression. So we have linear boundary equation. So the very simple, we are considering here only one variable. So here z is equals to beta 0 plus beta 1. So beta 0 is your intercept and beta 1 is your slope. Okay. So this is called to be the z is equals to this, whatever the means after turning, you will get some values of z, okay, beta 0 and beta 1. So that's what exactly your model. So you will, that is equals to z, okay, and what you will be, you will give this z to sigmoid function. So that right now your sigmoid function, you will that will give you the values from 0 to 1, and you will have some threshold. Okay, let's consider your threshold is kind of 0 0.5. So if your value above 0 0.5, then it is considered to be one class, and another means below 0 0.5, it is called to be the another class. Okay, so the loss function here utilized is called to be the cross, okay, entropy function, binary cross entropy function. If there are the two classes, and if there are multiple classes, then it's called to be the cross means uh, binary cross validation, and then the multi-class cross validation. That way it is called. Okay, so this is a kind of a loss function. So if y is equals to 0, then this is the particular function they are going to utilize. If y is equals to 1 and 0, so this is means if your class or this particular probability is reaching towards 1, then this value is becomes, this is your cost function, And if it's reaching towards the zero, then this is your particular cost function. So that way, this is a binary cross entropy cost function is the similar way where in linear regression we use the mean square error. Here we are utilizing the binary cross entropy to train our model. Okay, so this is kind of a illustrative example. So how your models are trained. So these are the red and the blue points you are able to see. And here my job is to train or come up with a line which will divide this data into a different two sections. Okay. So here you are able to see epoch. So I am running my algorithm again and again, again and again. And you are able to see this is the green line. Okay. So right now here you're able to see initially it start with some random slope and intercept. So 340. Okay, it started with 1 0. Right now you are able to see as we moving forward, you are again reaching towards the kind of a decision boundary. So learning or training of the model is nothing but a finding of proper slope and intercept in case of a linear regression also, and in case of a logistic regression also. But in logistic regression, you will get our decision boundary, but in linear regression, you will get a line. Okay, so that's what a basic difference. So here just we are finding the kind of a slopes and intercept. That's it. So moving towards the numerical, what type of machine learning problem is logistic regression primarily used for? So for what problem logistic regression is used for? So yeah, just we saw that and it's used for the classification problem. Sorry, the logistic regression here, regression mentioned, it does not mean that it is going to be utilized for the regression. So it's basically used for the classification problem. Linear regression is going to be utilized for the regression problem. So uh, just we discussed in the previous slide, that's what we discussed. Moving towards next question, in logistic regression, what is the output range of a logistic function, sigmoid function? What is the range of a sigmoid function? Read the question properly. Okay, so the correct answer for this is B. That's what we just told you that we want to convert our minus infinity to the plus infinity, whatever the value we are getting out of that particular decision boundary line. So we want to convert that into the 0 and 1 range, and that's why we utilize the sigmoid function. And that's what he asked here, logistic function, that is the sigmoid function is utilized, is what's exactly its range. So its range is 0 to 1. That's why the B is the correct answer. Okay, so moving towards next. So what is the purpose of sigmoid function in logistic regression? So what exactly the purpose of sigmoid function? Yes, you are correct to convert odds into the probability. That's what the main purpose, because you don't want from anything from the minus infinity to plus infinity. Because it will take very means to store that value. It's also difficult, as well as there are many other things also. Means it's very good to have the range between the 0 and 1. That will help to intuit it very easily. Okay. In logistic regression, what is the cost function that is minimized during the training? So loss function, cost function means loss function, which is utilized for the training of the model. Hmm. Okay, yeah, you are correct. So the correct answer is cross entropy loss is the correct answer. Mean square error, mean absolute error, root mean square error, all these are utilized. It is nothing but a y is equals y minus y hat whole square. All those things are basically utilized for the regression, but cross entropy loss is basically utilized for the logistic regression or the classification problem. So loss functions are different in both the cases, regression as well as the classification problem. So you should know that. Okay. Moving towards next. In logistic regression, how are model coefficients typically determined during training? Weights are typically determined during training. So I'm talking about here, how the weights and intercept typically determined during training. What thing we utilize. So the correct answer for it, calculated using the gradient descent. So we utilize the gradient descent method, and that gradient descent method help us to calculate and to reach. Actually, gradient descent method decreases your loss function. Okay, and decreasing in loss function, when it will happen? It will happen when you change your weights. That is called to be the your, if it's in simple words, your slope and intercept. If you change slope and intercept, then you are going to reach again minima. So that's what exactly happening during the training, and that's why calculating using a gradient descent. Which evaluation metric is commonly used to assess the performance of logistic regression? So these are the performance or the evaluation metrics. We not talked about it, but you can still answer. Means once you train the model on what basis you will judge that model A, model B, model C is the good model or something like that. So for this, generally we utilize the accuracy, precision, and recall or response score. R square, mean absolute or RMSE are basically utilized for the purpose of a linear regression or the regression kind of a models. Okay, so that's what I want to tell in precision. What is one hot encoding used for in classification? So, so this is I um, not talked about. So that's why I will directly give the answer. It's encoding means categorical variable as a binary vector. Okay. So one hot encoding, what exactly it means? So um, let's consider something like mm, um, color of a car. Okay. So if the color of a car, there are three colors in the car. If you want to prepare some kind of a machine learning model for let's consider the price of a particular car. Okay. So based upon that, you have a color that is a black, white, green. So you can't directly give that color name in your model. So what scientists come, because your model not learn the language of the world language. So what generally people do? So they will take one and all other zero, all colors other zero, means that will represent this is the color is the black color car. If that particular color is the white, then that particular variable is considered to be the one, whereas the color of all other colors or variable are considered to be the zero. So that way we are going to give the variable, and that is called to be the one hot encoding. Convert your categorical variable means color of the car, then how many number of wheels, two-wheeler, this is three-wheeler or four-wheeler. So that is also categorical variable, but it is a number. Okay, so that help us to convert into the binary vector. Okay, that what exactly it means. Next question. Uh, in binary classification, what does precision measures? So this is also, I think, we are going to cover in the next. I think that is not take on that portion. So this here we will learn about that. So right now you collected the data, you trained your model, and once you train the model, so while training you will train the multiple models. Okay, so it might be the linear regression. So you will not only train the one linear regression model, you will train multiple linear regression models, and or the logistic regression model. So which model I should deploy in my production? Production means in real life. So that what we have to test it. Okay. So even if you prepare one linear regression model, one random forest model, another one is a neural network model. So which one is the best for your particular task? So in that case, you should validate that with a specific thing, and that can be validated with the help of different matrices. So here there are different matrices are given. Okay, so this can be generated with the help of simple table. Okay, that is called to be the confusion matrix. Hmm. And this confusion matrix, how it is formed. So you will take a kind of a data set, means you have a particular train your model, and then on the testing data set for each sample, whether it is correctly predicted or not correctly predicted. Based upon that, you will give a number to it. So let's consider we have 1,000 testing samples. Okay. So here, surely that is, so let's consider the example of COVID patient. So in COVID, particular patient actual means actually he is positive, and when you do the COVID test, okay, what exactly results come. Okay, so let's understand this particular whole confusion matrix with the COVID example. So hope most of you had a COVID positive. Okay, so you are able to understand, and there are at the time they are saying that whatever the testing kits are coming, they are not giving a correct result and all. So all those things, whatever the uh, things which we are saying, that can be concluded with the help of this confusion matrix. So assume there are four possibility. Actually, patient might be a positive or negative. Okay, so that are the two possibility. Then, if you perform the COVID test, there are two possibilities. Your COVID test, either it comes a positive test or it comes a negative test. Okay, so with positive and negative for both actual and a COVID test after whatever the result coming, it divides into the four, what you can say, combinations. So if consider I am positive, okay, and my COVID test also comes positive, it's good. Means that is called to be the true positive. Okay, that kind of a type. Okay, that kind of a particular this combination is called to be true positive. Now, if you are positive, okay, and whatever the COVID test you did, it comes out to be the negative. That is called to be the false negative. Okay, this is very dangerous. Okay, this kind of situations. You are positive and your test is negative. That means in your house, you are a carrier. Means you did, means you have the symptoms and all. You went to the hospital, you did your test, and it comes out that you have a negative test. And then what you have, you went to your home. There are so many family members, your small children here, you are playing with them, and you are coming in contact with them. That's why you are transferring your disease to the other members as well. Okay, so here this is called. That's why it's kind of a red. We want to avoid this kind of a situation. That is called to be the false negative situation. Okay, then another condition is negative and positive. Means actually you are negative, you don't have any symptoms and all, but whatever the COVID test comes, it is come to be the positive. Okay, so there are many people who are means quarantine. Their whole society is quarantine, and they are in TV. They are coming in the TV and they are saying that we don't have any symptoms, even though no cough, nothing. Even that, even though means our positive means our test, whatever the conducted COVID-19 test, it comes to be the positive test. Okay, so this is also a dangerous situation because so many people are admitted to the hospital, and that's why I think because of fear also so many people got died during the period of COVID-19. Okay, so this is called to be the false positive case, and that's why we also want to avoid this kind of a cases. Let's assume another example of this, okay, to make it more clear. Let's assume you don't have any cancer. Okay, actually you don't have cancer, but doctor conducted the test and you come up with a, what you can say, a cancer. Means actually you don't have cancer, but whatever the test they gave to you, they are telling that you have a cancer. Then they will recommend you a chemotherapy, and chemotherapy is very costly as well as it is very painful. Okay, even though you don't have anything, they are giving you the medicine. Okay, so that will again destroy you, even though your body functioning good, or you might have the another disease, but you are taking the medicine of the another disease. Okay, so that's even a more problematic case. That is the case of false positives. And negative means you don't have anything and your test comes to be the negative. That is the good way. Means, so we generally want to increase the TP, TN, and we want to decrease the FN and FP. So here that way we are going to this four blocks if you are able to see. So false negative is called to be the type 2 error, and false positive is called to be a type 1 error. That way this confusion matrix is divided. Now, based upon this TPT and all these four values, there are different metrics. So just take a snapshot of this. Okay, so that will be helpful you while doing the calculations in the means what you can see in the paper and all. So this is very basic formula here. What sensitivity means, they will take a TP and they will take the sum of TP plus Fn. Then specificity means they will take a Tn, okay, and they will kind of do Tn plus Fp. Okay, so these are kind of means they are taking the diagonal elements here, and then sum of these two means kind of a particular this column, particular this row. This row again they are taking sum. Here they are taking sum of a particular column, and then these diagonal elements. So that's why they come up, and then accuracy. Accuracy means these diagonal elements. TP and TN are positive means they are giving the correct result. So it accuracy, what exactly accuracy means? Correct divided by whatever the test I did. That will tell the accuracy of your model. Means I did the 100 test, and out of these 100 tests, 80 tests, whatever I did, that person is positive, I give the positive result. If person is negative, I give the negative result. Means I give 80%, 80 result go means actually, but 20% there is a error. 20 in 20 result there is a error. So that's why your model accuracy becomes 80%. Okay, that's how the basic funda of accuracy and all. Okay, so these are the different metrics called the precision, sensitivity, specificity, negative predictive value, all those things. So hope you understand this is the metrics help you to in the classification problem. Okay, all medical test and all. So whenever they are calling to be the false positive or negative, so they are referring to all these things. Okay, so moving towards what is the purpose of confusion matrix in the classification? So just we saw in the previous slide that's called the confusion matrix. So multiple option kind of means here you can say correct, but you have to choose the most appropriate one. So yeah, most of you guess it as a C. It accesses the performance of the classification. It measures the accuracy of regression model. It's not measure the accuracy of regression model. It's measure the accuracy of logistic regression model. That is the correct answer. So C in this case, C is the correct answer. Okay. Someone give A as a the to visualize data in 3D space. I don't think so. Visualizing data in 3D space. We are not visualizing data here. So C is the correct answer. Moving towards next. In binary classification, what does precision means? So it's a true positive divided by true positive plus. Um, so it's the ability to correctly identify the positive instances. So let's see here. So this is kind of a precision. So this is false positive. Yeah, so here you can say the ratio of a true positive to all positive prediction. That is also a correct answer also. So this is vertically correct, and this is kind of you can say the mathematically correct option. So A and C both are correct here. Okay. Now moving towards next, in a binary classification problem, okay, if a model makes 80 true positive prediction, 10 false positive prediction, 5 false negative prediction, and 105 true negative prediction, what is the accuracy of the model? So this is very simple based upon that particular confusion matrix. So I give all those TP, T up, all those value, TP, TN, uh, FP, FN, and based upon that you have to tell what exactly the accuracy of that particular model. Okay, so okay, I will give you the formula. Those who are not able to see, so this is the formula of accuracy. Okay, so these are four things I already given to you. Four, and these are all two. So take a snapshot and then calculate your answer. So this is the question. Okay, so the correct answer for this is 0.92. 92% is the accuracy. So this is very basic calculation. Total predictions, you have to sum it all, and then TP plus PN is 80 plus 105. So it's 185, and then divided by 200, that should be 0.925. So the correct answer is the B is the correct answer for this. Next question is, a classification model predicts 120 instances as positive, out of which 100 are actually positive. What is precision of the model? So model predict 120 instances as positive, but only actually 100 are positive. So precision you have to calculate here. So that table, just remember that table. That table might create, I mean, so many, means you can create so many, what you can say, numerical type of questions from that. Okay, so you should remember that. Correct answer is C, yeah, most of. So it's very basic. So TP is equal to TP plus FP. So 100 and 100 means it's showing that the classification model predicts 120 sample. That means 100 plus 20. So that's equal to 0.8. So that's very basic answer for that. Next one is another way to evaluate your model, that is called the ROC curve. So what exactly ROC curve means? ROC curve is a graphical, so this is a graphical representation. Based upon that, you can say my model is good or better, best, or something like that. So it uses used for classification from particularly in machine learning and medical diagnosis. Okay, so what how this particular graph is done. So true positive rate, that is called to the sensitivity, and one minus specificity. So these are the two measures, that is called to be true positive rate or true positive false positive rate. That what exactly it is called. So we are going to take these two, and we are going to draw a particular graph or this particular plot on that. So here, this particular red line you are able to see, that is the random classifier. Any random classifier if you take, that will give you this kind of performance. So that is called to be the very baseline. If your model going, means if your like this particular line, whatever you are going to draw, if it's going towards below this particular rate line, then it's called to the worst model. Worst. If it's going above this, it is called to be the better model. So here you are able to see orange, means blue is better than green, green is better than orange, and orange is better than red. And if your model coming here, then that is called to be the perfect model. Okay, so how these particular things are calculated? So what basically they do, so they will take a particular threshold. You are able to see here this particular graph, that is a sigmoid function. What they will do, they will take this particular threshold, they will take threshold is equal to 0.5, and then for 0.5 they will calculate the true positive rate and false positive rate, and they will put that particular point here. Okay, so from 0 to 1 they will give the different y value threshold, and based upon that you are getting for that different threshold. Okay, 0 to 1 you will get different true positive rate and false positive rate. And so like this here, after changing different threshold, you are getting different values of true positive rate and false positive rate, and based upon that, this particular plot is done. And that this plot means, if you consider this is for the random, means logistic regression, this is random forest, is neural network, then neural network is the best plot for this particular model. So this is the graphical way to uh, check whether my model is called means better or not. So that is called to the receiver operating characteristic curve. Next, move towards our numerical. If the classifier has true positive rate of 0.9 and a false positive rate of 0.5, what is the specificity of a classifier? Specificity of a classifier. So just have that kind of a confusion matrix with you. So the correct answer is 0.85. So this is the specificity, is nothing but a 1 minus false positive rate. That's what we just saw here. 1 minus means false positive rate means 1 minus specificity. So what exactly specificity? It's 1 minus false positive rate. So just to look this kind of a numerical way, means just a twist. What we just saw in the upside, that's what I asked. Next question is the classification model has 122 positive, 2 negative, and 30 false positive. What is the false positive rate of the model? Yeah, the correct answer is A, because false positive rate is FP divided by FP plus PN, and that's what here we put it the value 30 plus 30 plus 2, and that's fine. 0.2 is the correct answer. So that's it for the today. I think we cover all the things. So most of the questions will be asked from this particular table. Okay, just take the snapshot of this, and when you go to the exam, just in mind, uh, prepare this kind of a table that will be very helpful for you. So this is kind of actual here on the left hand side, on the top side predicted, and just put here TP coming in the diagonally, FF coming non-diagonal elements, then positive on the left hand side, negative on the right hand side. That way you can able to remember this. And this, if this is in the first column, it is called to be the precision. If it's in second column, it's called to be the NPV, that is net negative prediction. If it's diagonal, it is accuracy. So that way, if you remember this particular thing, no need to means confuse with anything. Okay. So if you have any question, you can ask, or we can conclude here our session. So with the numerical, I think most of you able to solve the question. So I will upload this again on the YouTube as well as these things.